This video is made possible by the Hawaii Institute of Geophysics and Planetology and the University of Hawaii at Manoa's Department of Earth Sciences. Mahalo. The sun and the moon together create chemical compounds on the lunar surface. I'm looking for something that's been predicted chemically but has not yet been detected. Aloha mai kako. My name is Chiara Ferrari-Wong, and I'm a PhD candidate in Earth and Planetary Science. And this is the search for hydrogen-carbon compounds on the moon. Hydrocarbons are organic chemical compounds composed most basically of hydrogen and carbon atoms. You've probably heard of a simple one called methane. It's fairly common here on Earth and is formed through the decaying of organic materials. Some mechanisms for this include the decaying of plants in wetlands, the burning of organic materials like wood, and even livestock emissions, like through cows. Methane was first detected in lunar samples in 1971, and later was detected in the lunar exosphere in 2016. But unlike on Earth, the production of methane can't be attributed to a lunar dairy industry. Instead, the evidence points towards something called the solar wind, a stream of charged particles coming from the sun's upper atmosphere, composed of mostly hydrogen and some carbon. On Earth, our magnetic field deflects these ions, but the moon lacks a global magnetic field, so these ions can then become implanted into the surface and undergo chemical reactions. We know that methane on the moon exists, but we also predict a variety of other compounds whose reactions are possible on the surface. But unlike with methane, these compounds have not yet been detected. Now this is where the plot thickens, because many of these compounds have low vapor pressures and might not want to stay around on the surface long enough for us to detect them, much like water evaporates quickly on a hot day. But there is one mechanism that might be responsible for keeping these products on the surface for longer periods of time. Micrometeorites are small impactors that strike the moon at very high speeds. When they strike, they can melt the surrounding soil, forming glass and possibly trapping compounds like a fly in amber. If this is the case, then we should be able to detect some of these trapped compounds on the lunar surface. This process of volatile formation through solar wind and micrometeorites on the surfaces of airless bodies is not well understood. So a perk of studying the formation of volatiles, such as hydrocarbons, on the surface of the moon is that we could better understand this solar system-wide process. Additionally, understanding the presence and formation rates of these compounds is important for the upcoming human return to the moon via NASA's Artemis program. As humans start to establish a presence in lunar orbit, or even deeper into space, it becomes increasingly important to understand the local resources available to generate products in space, also known as in situ resource utilization. If we understand the reservoirs and formation rates of these products, we can better understand where to go to find them and also how to utilize them sustainably. So how do we plan to look for these products? Well, most organics have a unique spectral absorption feature in the near-infrared known as the carbon-hydrogen stretch. I'm looking for this unique spectral feature using ground-based observations at the NASA Infrared Telescope facility on Mauna Kea. Our primary goal is to determine if there is a carbon-hydrogen absorption feature on the surface of the moon. If we can't find one, it might be because it exists in amounts too small for us to detect through our observation method. If that's the case, we'll have to determine detection limits of our telescope. If we do find one, we'll want to quantify the amount of hydrocarbons detected, as well as its location on the moon. We've taken thousands of spectra so far, but the search has just begun. Who knows what we'll find? You'll just have to stay tuned.